I'm David Majda, and you can find me as dmajda on Twitter, GitHub, and elsewhere. And today I will talk about my project PEG.js, which is a parser generator for JavaScript. So first, a little bit about me. I studied computer science at the Faculty of Mathematics and Physics here in Charles University in Prague. And during the studies, I got interested in programming languages and everything that's related to them, which shown in my master thesis, which was Ruby to PHP compiler, which sounds kind of crazy. But it actually taught me a lot about parsing, about compiler construction, code generation, and other topics that got quite useful when I started working on PEG.js. So after school, I did some freelancing, and after that, I ended up in SUSE, the Linux distribution company, and I worked there as a software developer on SUSE Studio. I say this just because PEG.js is totally unrelated to my work at SUSE, so it's my project that I do in free time. So what's the story behind PEG.js? 3 years ago, I, as every programming language nerd, decided that I have to create my own programming language. So I started to look at a lot of other languages, start writing notes, examining ideas, thinking a lot about that everywhere I went, talking to people and so on. And after like 3 months of this, I decided, okay, I have to prototype this, start actually working on it. And at the time, I decided that the language would be written in JavaScript and actually compiled into JavaScript. Now this is obvious idea because we have CoffeeScript, TypeScript, Dart, and other languages that are compiled in JavaScript. But 3 years ago, that wasn't like the most obvious idea. So the first step when you create a new language is writing a parser of that language, which is the piece of code that converts the source code into some internal representation that you work further in the compiler or interpret of the language. Usually the internal representation is a tree called syntax tree, but it can be anything else. And writing a parser is quite tedious job. On one hand, it requires quite some intellectual effort to get it right. But on the other hand, there is a lot of tedious stuff in parsing. You do a lot of repetitive work, and the code isn't very pretty, so people don't like doing that. So a long time ago, smart folks thought about generating parsers. So parser generators were born, and there are tools that take some high-level description of a programming language syntax called the grammar, and they produce code that parses some input that matches that grammar, and produces the internal representation that your tool needs to use, or it can produce an error when the input doesn't match the grammar. So there are some things that a good parser generator needs, some properties that it needs to have. So in my opinion, the most important are 3 of them. First, it needs to be easy to use, meaning the grammar syntax should be expressive, intuitive, shouldn't have too many gotchas, and so on. Second, it has to generate parsers that are fast, so that parsing doesn't slow your compiler, interpreter, or whatever down. And third, it has to produce parsers which have nice error reporting, so users of your language are able to debug syntax error easily and don't spend too much time with them and don't end up being frustrated. And at the time, I also looked at formalism for writing parser, for writing language grammars called strings. So what is a string? I would say it's a quote. Then it's something, quote. Then something that's not a quote. And then there can be 0 or more of these. And the ending one. So that's, for simplicity, that's what we consider strings now. So let's try to parse one. All right. So again, we have this problem with that the output doesn't match what we think or what we would like here. We would probably like the string literal. So we can solve it in a similar way like we did before. So let's write chars here and join them. All right, so this works. You can see that this become a little bit tedious. Usually this isn't repeated on more than 2 or 3 places in the grammar, in the lecture part, basically. But I already have a branch where I have some syntax that will do things like this automatically and just extract the string that is matched. It's just that it isn't released, so I won't show it here in the demo. So, what about if we want to include escape sequences in strings? Right now, this doesn't work. So we should probably define some rule for escape sequences and include it in the string rule. So for for simplicity, we will just define escape for quote. So we will use backslash and quote. We could probably even join that together. Doesn't matter much. And we will just return a quote there without the backslash. So we will unescape this thing. And now we can use another feature of PEG.js, grouping. So we will say, okay, the characters is a list of 0 or more of either escape or something else than quote. It would probably be cleaner to name this, but I won't do this now. So you can see it already parsed the input perfectly, and the backslash here is escape because this is JavaScript dump of the structure, so it's written in JavaScript syntax where the quote needs to be escape, but yeah, it does what we want. So what's next? Arrays. So what is an array? So first thing is an empty array. So this is something like this, and we should probably return an empty array here. Or it's something else, and we will have some items inside. So what these items will be? It will be literals, probably. Yeah, so so there is at least one literal when this is not empty, and then there is a list, possibly empty, of comma and another literals. So let's try it. All right, it works, but it produced something else that we want. So again, we will have to write some code to produce a nicer output here. So first thing, we will name this thing first, and we will name this thing rest. And what we want to do, we want to concatenate. So we want to return basically an array. So we will make the array of the first element, and we will concatenate the rest, see what this does. So this almost works. You see, we have just one array. The first item is indeed the first element, but the second and third things are still arrays. Why? Because this thing in the star operator has 2 items. So there are several solutions to that. Either we can write an action here that would transform these 2, or we can use map here. So I will.
Can you just push the rest label into the group?
Actually, no. That's that's one of the extensions that I will probably. I don't know if I will do it or not, but it's something that people request actually, and I can somewhat understand it. But it would have some implications. Like if this would be named rest, and then there would be an action here which would use that variable. Then the rest variable would mean something else here inside and then outside of it, because then it would be array of some things. So I find it a little bit weird, so I'm still not decided whether I will implement it this way or we'll see. So what we can do here is do the mapping. So let's map the elements and oh yeah, right. Okay. So you see the output is okay now. Rest square. It's an array. That rest, the rest would return the something like array of 2 and of a comma and 2. So that doesn't make sense. The rest by itself is an array. It's an array of other arrays which all have 2 items. The first item is comma and the second is the literal. Okay. That's what Martin asked before. All right, but it's good to see these questions pop up because it makes me think that. Yeah, yeah. I see the pressure. All right, so this works, but what if we write space here? So you see that immediately the parser stops to work. So in PEGs, you don't have, you may be used to from other parser generators and parsers in general, that they skip white space commands and so on, and you don't have to write them in grammars. So this is not the case in PEGs, because there is no separate lexing and parsing pass. So we have to do this manually in the grammar. So I usually define some rules like this, and put the underscores on proper places. Of course, users don't like this too, so I have some thoughts about how to solve this, and I will probably solve this soon in some way, so this can be automated. Yeah, and of course we need to do this. Okay, so this is arrays. Now you can put spaces wherever you want. So let's add objects. So an empty object looks mostly like an empty array. There is no big difference. And non-empty object. All right, so it will be again a list of things, but this time instead of literals, it would be some key value items. So I will key value pair. So I will name these items. I will do this. All right. And first I will define what an item is. So an item would be some identifier. That would be the key. Then there would be a colon. And then there would be a value, which would be, well, literal. And there are various options of what we can return here. So I will just return a simple object with with a key and a value keys. And we have to define what ID is. So for simplicity, I will just do something like this. in real world, the identifiers are a little bit more complex, but let's not dive into this now. So, I'm missing plus here. So this doesn't return what we want because we didn't write an action here. So what we actually want to return is object literal. So let's start with an empty one. Then let's add the first item, the key and the value. So let's do something like this. And then we have to do the same thing for the rest array. So let's iterate over it. And return the value, the result. So, something strange happened. Yes. It's interesting, I did the same mistake when I was practicing this talk. I still didn't learn to avoid it. All right. So now we can pass objects, and then the only thing that's missing, we should say that JSON is either an array or an object. And voila, we're done. So the only way this differs from real JSON is that it doesn't parse floats, and it has a simple syntax for strings and the identifiers. So these are just trivial extensions that you probably can imagine we could implement if we wanted. So you saw that I wrote this grammar interactively in like 10, 15 minutes or so, and it wasn't anything hard. So you can use PEG.js to write grammars for languages, for templating engines, for a lot of other things, query languages. Basically anything where the regular expressions isn't enough, you should probably think about writing a proper parser, and PEG.js is a good way to do this. I have a list of projects on PEG.js wiki that use PEG.js. The list is actually incomplete because I just searched through my email and Twitter, and there's a lot of projects that I must have missed this way. There are two quite important projects that I want to point out. First is CoffeeScript Redux, which is a rewrite of CoffeeScript by Michael Ficara. He tries to rewrite CoffeeScript in proper way, to be more structured, and he uses PEG.js as a parser generator for that. And another project is listed somewhere down here, ql.io, which is a HTTP API query language. And I mention it because it's created by eBay, so even some big companies use PEG.js by now. So PEG.js right now is at version 0.7, and I am slowly going to 1.0. And as you saw, there is still some stuff that needs to work. So this is kind of tentative roadmap for the development. So the first thing I want to do is create a new code generator, which is the part of PEG.js that actually generates the JavaScript code. The current code generator is pretty messy, honestly. It uses a templating engine, and it can be done a lot better. And more importantly, it generates only parsers that are optimized for speed. And there are a lot of people who want parsers that aren't necessarily fast, but that are small because they push them to clients through the browser. So the new code generator will work like this. It will create bytecode from the parser, from the internal representation of the grammar. And then, when you specify that you want a fast parser, it will just generate code that is similar to the one it generates today from that bytecode. On the other hand, when you will say that you want a parser that is small, it will just embed this bytecode, which is just a string of numbers, in the resulting parser, and then it will append small virtual machine, something like 100, 200 lines code, that will interpret that bytecode. So that way, the representation of the parser would be very, very compact. You may ask why we can't have both, like the parser that is fast and small at the same time. Well, the reason is that JavaScript that is small isn't fast, basically. So I actually do benchmarks and all that stuff that Felix recommended. And so I measured a lot, and I found some results which sometimes are very different from what he found. So for example, with functions, functions usually you think about as cheap, but when you have a function that's called for every character in the parser or something like that, and you are passing a megabyte of data, then it becomes very noticeable. So according to my benchmarks, it helped a lot when I inlined a lot of helper functions and just put the code there, which of course increased the duplication in the parser code and increased its size. So this is a place where the two goals are contradictory. And there are some more similar things. So this is why I'm going to include this option, either small or fast, choose. Then I want to work on usability improvements. So I mentioned that during the demo, there are some rough edges, some stuff that where there is some duplication in the grammar that's not that necessary. So for most of these, there is already some discussion on GitHub with users. And I'm trying to find solutions usually which have most expressive power, aren't some just hacks around specific situations. And I'm trying to keep PEG.js simple along the way, so it's not easy. And I'm kind of a very conservative guy in the sense that I am very reluctant to include new features and new stuff, because once you add something to the grammar or somewhere, you can't remove it. So yeah, I really need to be convinced. So usually what convinces me is people like writing 15 comments on the issue on GitHub, then I say, okay, maybe you guys are right. Well, I usually go by the issues which have most comments. So like it has to be 15 when there is other that has 14. Yeah, so if you create like 15 fake accounts on GitHub and start putting comments there, that is a way how to include feature in PEG.js, but yeah. So this is, another thing is that I want 1.0 to have stable API, so people can really depend on it, and the API, I don't want to change it much after that. So there are some stuff which I didn't show, like custom error messages and all things that aren't done in a best way and in a way that can sustain, I think. So I will need to rewrite that and create a stable API. Part of this is also creating an API for plugins, because people want to do crazy stuff with PEG.js and extend it. So they want to generate C code from the grammar, or they want to generate syntax highlighters for languages described by PEG.js into editors. Some of these people sit over there who want to do that. So all these things I need to kind of accommodate for. So after 1.0, I want to focus on other topics. One obvious one is composability. So PEG.js, in PEG.js, it's easy to put one grammar into another on a theoretical level. When you have a PEG and include it in another PEG, the result is still a PEG, which is not true for all parsing formalisms. And you actually want to do it in a lot of cases. For example, the grammar syntax. You have a rule identifiers there, and the syntax for them is the same as for JavaScript identifiers. So at the current implementation, I just copied the part of the grammar over, but I want to be able to say, okay, or just reuse this part of JavaScript grammar. And there are a lot of other similar cases in the wild which need that. Then there are some bigger topics, like, for example, rule templates. This is something which I still haven't decided whether to do or not to do, but there are some obvious use cases. For example, in JavaScript, you have arrays which are list of some items separated by comma. You have objects which are list of something else, the key value pairs, separated by commas. Then you have variables which are lists of variable names or assignments, separating by commas. Then there are function arguments, which are a list of arguments separated by commas. Then you have statements, which are a list of statements separated by semicolon, new line, or whatever. So you see there are a lot of applications in some grammars which currently need to be reflected in the PEG.js description. But I want to include some templating, so you would be able to write something like list of this separated by that. And this template would just generate the right code for you and automatically return arrays. But this is pretty complex feature, so we will see if I will do it or not. And another thing is streamable or interruptible parsers. And this is quite a big topic. Currently, the parser just has a parse function. You will pass your input to it, and it will return some result or throw an exception. And sometimes this is not desired because, for example, in browser, the parsing, if you pass big data, will block the UI. You can work around that with web workers by now, but that's not always possible, and there are cases where this is actually not helpful. Like, for example, you will have an editor, and you want to parse the stuff inside the editor because you want to do some analysis in the background and so on, and you are in the middle of a text and start editing. So why should the parser reparse the whole thing from the top to the middle where you are editing? It should start parsing somewhere in the middle. So if it can save its state and it can return to its saved state, this will be possible. And on the node side, there are similar issues where the parsing can block the thread in Node.js, so it can't accept more requests. So yeah, this is some quite clear use cases, so I will probably do that. If you want to follow development of PEG.js more closely, there is a Trello board on this URL. So there are some fine level tasks. Yeah, the most important is the done. I actually created the Trello board. And this is on a more fine-grained level than the roadmap I shown. So if you have some pet feature and you are wondering why I'm not working on it, you can see the queue of features before it, and you can actually vote in the Trello board, so that's another way how to push features into PEG.js. You can't currently comment here because I prefer people commenting on GitHub, because that way there is just one place where to put comments. Yeah, so that's all I wanted to say. PEG.js has a website with documentation, the online tool which you've seen. There is a Twitter account, which if you are interested, you probably should follow. I try to not spam my followers, so there is something like 1 tweet per week or so about new features and other things. There is a Google group where both usage of PEG.js and its development is discussed, so you can join there. There is a Trello board, and of course there is source code, wiki, and issues on GitHub. So that's all for me. I hope that you find PEG.js useful and that you will use it on some of your projects. Thanks.
Some questions? Okay, I go with.
Hey, first of all, thank you for working on this. This is really cool. And I'm pretty sure that if you do the streamable stuff, then people like me don't have to suffer through writing parsers anymore for protocols either, which would be really cool. So 2 questions based on that. The one example, I think it was the digits, where you were showing the inline function where you were joining them. So that it was looking like a regular expression. And me, as a regular expression user, I would expect the plus operator to match all the digits. And I think, I know why you don't want to do this, but have you thought about taking this regular expression idiom further and supporting the question mark after the plus sign as kind of a non-greedy matcher? Because that would solve the problem. If it's just a plus, it means match all the occurrences of this thing after another. And if it's a question mark after the plus, then do non-greedy, match each of them individually.
I didn't think about it, and users didn't request it so far. So.
Okay, I requested, and I need 14 more people, right?
Yeah.
Second question, so the streamable stuff sounds really cool. Are you also interested in adding binary data support, or are you focusing on text? Like,
I'm focusing on text right now.
Okay. But is there any reason why this stuff wouldn't work for binary data? Like, I couldn't imagine parsing, for example, GIF files or something like this really easily over the MySQL protocol.
There is no real reason why it shouldn't work.
Would you accept contributions for binary data?
Yeah, I think yeah, there are set, okay. The problem is that binary formats are often structured in a way that makes them escape this or get out of this PEG formalism. So this is probably why PEGs aren't that suitable. For example, you often have in binary formats count which says, okay, there comes like n bytes after this, which contain something. This is something which the formalism can't cope with. So of course there could be some extensions done to deal with that, but this is, yeah, there is just a mismatch between these two.
You need some state and back references, right, to make this happen? Like in the parser, like you need to be able to reference state from a previous parse operation or something.
That's not needed for this thing. This thing basically be able to add like something like repetition operator with in regular expressions, like the curlies, and then to be able to put something from elsewhere which you passed into this. So this would be the extension that would make this available, the feature work. So yeah, it can be done, but right now I think most binary formats probably will be tough to parse because of these issues. But if people want to do that and will yeah, create issues with enough comments, I will probably accept these patches because yeah, I understand that writing binary parsers with PEG.js can be productivity improvement.
Cool. Thank you again for working on this. It's really cool.
Thanks.
Some question? No? Thank you, David.
When you are damn too quick, I wanted to ask, a name comes to my mind, Bison. Yeah. Why do we have you chosen, there is some formalism to writing grammars, which is probably,
Sorry?
There is a formalism, Bison, the Bison supports some sort of formalism to writing grammars. You probably did choose your own formalism, your own syntax. What was the key decision, the key reason to do this?
There were several reasons. First is that in the original language which I wanted to create, I wanted basically stuff like string interpolation, like you know it from Ruby or CoffeeScript, where you do something like hash, curlies, and some expressions inside. So to parse things like this with Bison or another LR or LL-based tool, it requires hacks because you are mixing lexical and syntactical analysis that way. So the string isn't now just one lexical element, but it's something that can contain a whole bunch of things that are at a syntax level. So this wouldn't be suitable for languages like that. And when you look, for example, in Ruby implementation, they have tokens like string begin, string end, and they just have to work around that a bit. So I didn't want to do that, and PEG.js would, or PEGs as a formalism would allow me to skip these hacks. And another thing is that I found PEGs an elegant framework. They are more expressive, and the semantics matched what I wanted to do with the grammar, I wanted to have there. So it was more like aesthetical thing where I found, okay, this is really how I would want the grammars to be. That's not the case with Bison, and yeah.
Great, thanks. And if I wanted to parse Jabber stream, XMPP stream, do I need to wait for the interruptible or streamable stuff you are going to implement, or could I do it right now? Because I tried to do it with some of the shelf C parsers, and they were all caching. I was just sending a message that it was not getting the events, or I was not getting any output because it was waiting for some bytes to come, and then finally it started parsing. So can I use PEG just right now to parse the XMPP stream of messages? Or?
I know too little about XMPP to answer that conclusively. But if the chunks you send over the network are some self-contained piece, so there is not like there is open paren and that's closed in some another chunk or something like that.
It's a normal XML document, so there is some opening of the root element, and then you just go to stanzas, which are XML markup elements.
Yeah, then I think it should be doable.
Great. And I always wanted to format CSS and HTML in my own way. The editors do all it wrong. Could I use you? Is there any? I was scanning your list and I didn't see those two languages over there. Is there any activity in this area?
I know there is some JavaScript formatter tool which pre-prints JavaScript, which is based on PEG.js. In the examples, I have CSS grammar parser. So if you take it and add some processing and serialization of the resulting syntax tree in the way you want it, it's pretty easy to create a tool. So yes, PEG.js can be used for that. Great.
And one last question.
You have 3 questions, sorry.
This is really crucial.
I will be in a pub in a while.
URL, there is a SI or S big L over there? Trello, your SL or big I, it's...
I don't know, click the link.